Okay, so let's try 20. Oh god. Let's try tripping over a chair, spilling potatoes all over myself. Let's try 23 and 24 and 17.3. So we are supposed to provide an example of a vector field, right? You might recall that when I'm writing this symbol, what I'm thinking of is F maps R2 as points to R2 as vectors, right? Or R whatever as points to R whatever as vectors. In this case, I'm probably going to do two-dimensional vector fields because those are probably easiest for me to visualize. You could certainly do three-dimensional vector fields if you felt that was necessary. So for 23, they want me to find a constant direction vector field where the magnitude isn't constant. So can you draw a picture of something that's constant direction? Like, what do they mean by that?
Well, they're all going the same path, like a patio.
Yeah, this is the patio, right? All the water that hits the patio should all flow in the same direction. So from any point, right, water should all flow in the same direction. Now, the picture that I'm drawing here is not what they asked for, because
The magnitudes.
yeah, the magnitudes are different, right? You see that?
So some lines will be longer than others.
Yeah, so to get what they asked for, I need to make some of the lines longer than others. So somehow I need to make this happen, right? Okay, so you should be coming up with f of x and y, right? That's some stuff to make this go on. So how do you do this?
For the
When it says constant direction, does that mean that all the vectors have to be positive, or can there be some that are negative? As in, all the vectors have to have the same slope?
Yeah, I don't care. They just all have to have the same slope.
So there can be some vectors that are negative, meaning that they're pointing in the
Oh.
opposite direction.
Constant direction, I don't know. That seems like no.
I don't know. That one's up for interpretation. I'm going to say no.
So 2x, 2y?
No. No, because those all vectors can be pointed away.
Yeah, because those will change, right? Those will be pointed away from the origin.
Yes.
Okay, yeah. Yeah. You have
So
absolutely.
maybe in polar they all have the same direction, right? Out.
You can do like.
But I think by this they meant all parallel to the same vector, right?
I think the assumption is that's in Cartesian coordinates.
Yes. So
Absolute 2x, absolute 2y.
no, that'll be even weirder.
What about y equals x, and then like they're all horizontal, and then like they all have different magnitude based on what axis.
That seems like a great idea. I don't know. Do something like this.
Yeah.
Right? X comma x.
But when you have to like square them, so like they're all pointing.
Oh yeah. Because now I'm at Wesley's, right? Like some of these point in the opposite direction.
Yeah.
So maybe you'd want to do like x squared, x squared. Is that the picture that I drew here? Not really.
Also, what is there? If a magnitude is 0, does it still have a direction?
Yeah, yes, it's parallel to the real vector.
Yeah, it's parallel to everything. We had to make that definition earlier, right? So I think all of these are parallel to the vector 1, 1, right?
So the closer it gets to the center, the smaller the vectors, and the farther it gets away along the vectors, only those vectors come back to haunt the
Along
other
the
vectors.
x-axis.
Yeah, actually by the center instead here, we really just mean when x is 0, right? So that's along the y-axis. So that's not this picture. Right? So that's like, here along the y-axis I have a bunch of 0 vectors, right? And then when I go out 1 in x, right? Where do my vectors all point?
1, 1.
Yeah, up 1 over 1. So I get kind of vectors like this. These are how long?
1.
Magnitude of 1.
Root 2.
Yeah, they're root 2 long, right? When I go over to x is 2,
4 and 4, 2 root 2.
Right.
Oh.
yeah, the vectors get bigger, right?
Same thing.
You guys all cool with this? So they all point that way. And these guys, right, also point that way.
And eventually, if you go far enough, they start to overlap.
Yeah, and if you go back far enough and draw your picture messily, they overlap, right? It's all good with us? Questions, Steels? This is one method, right? There are lots of other answers to this that are totally correct. You could slap a constant in either one of these, right? If you didn't want them parallel to 1, 1, but you wanted them parallel to 1, 17, what would you do?
So
Slap a 17 in the y coordinate.
basically, we just need to make sure our x's and y's had an even power and that there was the same applied to each.
Sure, but you didn't even actually have to do the even power. You could have done something like, instead of doing x squared, you also could have done like e to the x. That would serve.
Would it have to be the same variable twice, or could it actually be x, y?
No, of course you could do something like e to the x plus y and e to the x plus y.
No, I meant like x squared, comma y squared. Oh, yeah.
So that definitely won't. So that one won't work because they won't go in a constant direction. Right? Because as you change
Okay.
one of the variables, right, the other one doesn't have to go along with it.
So it just needs to be even, so that the negative is the positive.
Yeah, so really what you need is a constant slope, right? So you need the change in y over the change in x to always be the same. So you need, whatever this is, divided by that to be a constant.
Oh, okay. But wait, x doesn't work correct because it ends up in negative.
X doesn't work because I answered Wesley's question before I thought about it.
And then x.
Right? Wesley asked, is it okay, like, is constant direction like this okay? Like, are those the same direction?
They're opposite.
My intuition said those are opposite directions, so
They're
I
same-
said
they're
we're not
same.
doing that.
They're the
The
same
side-
direction if the magnitude is negative.
Yeah, which is a very reasonable viewpoint and would have allowed XX to work.
Oh, does that mean magnitude can be negative?
And that, but then you have.
So what do we mean by parallel, right? What did we use as a definition for parallel? You guys remember? So when I write this, if I write a vector u is parallel to a vector v, what do
they
I
have the
mean?
same slope. Is the derivative?
That's for lines, right?
The derivative is equal, maybe? I don't remember.
No, I mean these are vectors, right? So what does it mean for two vectors to point in the same direction?
The dot product, right, is
Oh yeah, you could say the dot product 0, right? Wait, no.
That's for
That's wrong. Cross product is the 0 vector. That would work. No, because then I'd have to worry about one. No, that would work. We could do that. I think it probably is better to take the definition as one is a scalar multiple of the other.
Okay.
But then, of course,
That includes the zero vector as well.
0.
no, that's okay. So the 0 vector still satisfies this, right? It's the one that for the 0 scalar.
The,
You guys all good with this? But what does it mean for them to point in the same direction? Well, to go in the same direction, I might say a very similar thing where k is bigger than 0. You guys see that? It depends on how you define in the same direction, and we didn't. Does that make sense?
Yeah.
Like I never defined that. I defined parallel, but I didn't define in the same direction. So this was ambiguous. An XX probably would have worked, but I told Wesley it wasn't allowed, so I had to commit.
it still wouldn't work because the other two quadrants would go that way. And that would be.
No.
What?
It's
No,
only
I
based
mean
on
I could
X.
do this, right?
What?
It's only based on x, it's not xy.
It's not X, Y. Exactly.
Oh, okay, sorry.
I mean, this isn't actually that vector field. You guys cool with this? All right, so how about number 24, where they ask for the magnitude of f is constant, but the vector field's not?
If a vector r divided by its own magnitude.
Yeah, how do you write that as f of x and y?
If it was vector r, can it be vector 3x squared plus y squared? Go from x squared to r, or the rectangle.
I mean, you got to fill these two dots in, these two slots in, right? What are you filling them with?
I was thinking if it's r, that'd be the same thing, like r squared is x squared plus y squared. So could you do root x and root y then? Turn that from polar to rectangular?
I think you're thinking the right thing, but we need to make sure that we're getting a vector field that's not constant, right? And I don't know what r is.
Could you now do like absolute value of x, absolute value of x?
Or x, y.
Hold on.
first
Oh, wait,
one.
no, sorry.
Let's start with the
Not
picture.
constant, yeah.
What would be a,
Yeah, a picture might be a good idea, right?
For example, first one could be
So I need the magnitudes to all be the same, right? Everywhere. So every vector I draw has to be the same length, right? So here's a vector that's a length. Here's a vector pointing in a different direction that's the same length. Here's a vector that's the same length. Here's a vector that's the same length. There's a vector that's the same length.
So,
All that matters is that they're all the same length,
so
right?
x over x, comma, y over what?
You mean 1, comma 1.
we could have x.
So that would actually work, except, right? So if you write 1, comma 1, that has the magnitude is always constant, right? But, crap, the vector field's constant. See that? Right, so I need to adjust the direction somehow. So, what do you do?
X divided by root x squared plus y squared.
Okay. And what's your other one?
Y divided by root x squared plus y squared.
and how did we get here? Where my big penis? How did we come up with this?
X squared plus y squared is the magnitude of the vector.
Oh,
So what you need, right, is you need to make a vector that has constant length, right? So how long is this vector f?
1.
That vector is x squared plus y squared long, right? Where this is whatever you put in the x slot, and that's whatever you put in the y slot. Okay, see this? So Wesley just started with, this is the vector that points at the point, right? This is the exploding vector field. And then he divided by the length. So this is the vector field that points straight out from everywhere.
Could we also do?
It's also number 6 in the book.
Yeah.
Could we do cosine squared x sine squared y?
No,
No?
almost.
What if they were both x? Because she's not.
You have better
the
luck,
equal 1.
but you still have problems. So if you do cosine squared x sine squared x, right, you're like trying to exploit the Pythagorean
Or
theorem,
y
right?
for the second.
Oh, y definitely.
No.
But you're trying to exploit the Pythagorean theorem, right?
Uh-huh.
So the Pythagorean theorem slash identity, whatever, says that cosine squared plus sine squared is 1, right? So you're trying to say, okay, this is always going to be 1 unit long. Except that when you figure out how long this thing is, you square this thing before you add it to that thing. So this vector right now is cosine to the 4th of x plus cosine to the, or sine to the 4th of y. Or of x, rather. And this is not the Pythagorean identity. Crap. So you could do this, right?
It's always equal to 1, right?
Because this thing's one long. Where does this thing point? Shit, I don't know. All over the friggin' place.
Yeah.
As you range x between 0 and 2 pi, what does the directionality for this thing do? Goes in a full circle, right? And then as you range x from 2 pi to 4 pi, where does it go?
Again.
All the way around in a full circle again. Well, sorry, I keep making that gesture the wrong way. It goes this way, right?
What if we made it y for the sine?
No, I think this is great. If you made it y for the sine, it definitely won't work, because then you won't be able to exploit the Pythagorean identity. Because you'll have cosine squared of x plus sine squared of y, and those don't go together. This thing's cool, actually. So as you go from 0, right? At 0, this thing points straight right, 1 unit long. As you get out here, as you get out here to, that's 1 now. I really want pi over 2, right? At pi over 2, it points straight up. It's still 1 unit long. At 3 pi over 2, it points straight,
At pi.
pi, it points straight back. At 3 pi over 2, it points straight down. And it does that for everything regardless of the y value. This is actually a really fun example. Right? And then it does the same thing in here. So you go over again and it does that again. This thing looks like a friggin' Konami code or something. Right?
Their own objects.
This is just mash your D-pad around again and again in a circle. Right? As you travel that way.
Some like G codes.
You guys cool with this?
Yeah, it's also how you kill people in Mortal Kombat.
Okay. I think Wesley's was probably a good example, and this thing is a strange example that's also good. You can do this with y's too. The important thing, right, is that you always have cosine of something plus comma sine of the same thing. So you could do this with even weirder shit, right? Like in here, it could be any function of x and y as long as this one was the same function of x and y. And as long as you didn't make it undefined anywhere. You guys cool with that? Probably avoid making things undefined. They're asking you for something where the magnitude is constant. I don't know what the magnitude of an undefined vector field is. Cool?
So does that look different based on where you slice your slopes out? Like if you did
This thing?
0, pi over 2, pi, 2 pi, if you chose like in between the typical points?
Yeah, so if you chose in between those, it'll just be kind of this guy, that. I'm just not drawing them because they're freaking, not that guy. So these will go relatively flat, getting steeper, pretty steep, and then these ones are weird because they cross over the top, right? But these are basically getting shallower as you go, right? That really is, as you travel between 0 and 2 pi in the x, your vectors are doing this.
If we had the magnitude, instead of being equal to 1, if we had it equal to pi over 2, I'm pretty sure we could get the arrows to all like point at each other. I actually...
I have no idea. Yeah, possibly. Yeah, you could do something screwy, like make all of these point at the same point as you roll around or something.
Yeah.
Cool?